let's stop right there. Did you see what happened? Well, if we try to see who actually struck first, it looks like it's blue. But you probably didn't see that, and that's actually one of the more prevalent problems in today's modern sports, wherein judges, they don't have the ability to see these split-second, very crucial moments. Although there are technology like video review or instant replay, there's still quite some controversy behind this, actually. Well, firstly, doing video review obviously delays the match or the game that's occurring, and that could anger fans, coaches, and it could also affect athletes who might feel a psychological impact from taking a pause from that adrenaline based physical activity they're doing. Another controversy, another argument that has been put up is that video review puts an unreasonable expectation of humans, and it's unreasonable to expect humans to perform or even react at that level. And as someone who has competed both in karate and judged at local tournaments, I've had firsthand experience with this sort of human subjectivity I'm talking about. Well, one type of bias that humans might possess is some color bias, or some individuals might be more sensitive to different types of colors, and that could impede their judgment. Additionally, in tournaments, especially whenever we're making a decision or a score, some individuals might face a conformity bias where they feel a bit doubtful about their decision when they see everyone else's decision. And lastly, we also see those officials or judges grade students or grade competitors more highly and give them more credit if they're part of their same country, their same nation, or their same club or school. So, how do we address this? And as someone who's interested in computer science and engineering, I felt like I had a sort of responsibility to address this problem and maybe try to find a solution to it. And in my project, I developed a computer algorithm that could take camera as an input or any video as an input and score these different sparring matches. And today I'd just like to go over it with you. The scope of my project mainly deals with sparring matches, and sparring matches are similar to fencing wherein this person right here could perform a kick to the head, and then that would translate to perhaps 2 points. Then, after someone scores, they reset their positions and they start again. And a lot of literature related to this topic actually is related to the domain of pose estimation. I was actually trying to review different types of work relating to my topic area with karate, martial arts, and computer vision, and a lot of them make reference to pose estimation. And pose estimation, what it does is essentially take an image like this person right here and then attribute these different types of key points onto that individual. And how pose estimation models typically work, it's not like this one, but it uses something called a convolutional neural network, similar to here. And the convolutional neural network, it sort of mimics the human eye and that receptive field that humans have. And see right here, it takes that snapshot right there. And then after that, it compresses that tiny portion of the image all the way down into a vector right here. And more mathematical functions are applied, and this generates sort of an output. And in this case, it was used for a classification task. However, in my case for karate, I wanted to use it for pose classification of different techniques and moves. And actually, one of the most commonly used pose estimation techniques is actually calculating joint angles. And what I mean by that is looking at this man over here. This man right here has this joint right here. That could be his left shoulder. And what many researchers have done, and what I implemented in my project as well, is to calculate sort of the angles between perhaps this person's shoulder and his right hip. And I do that for multiple different body parts. And to recall, my project deals with karate, and there's a lot of motion behind it. But motion is essentially a sequence of movements. So what you could actually do, and what I did for my project, is that you could take a sequence of these different coordinates and key points, and then you could pass it on to a different sequential model that could process this sequence, and you could classify what technique that person used. And the model that I use to classify these different sequences here is a LSTM model, a long short-term memory model. And what it essentially does is it takes one input at a time and processes it into this cell right here. And this cell, it's very similar to what a neural network does, and that convolutional neural network where it applies math functions to it. But it's interesting in that it has this long-term memory here denoted by CST. And right here as XT1, that could be the first set of joint angles right here, and it could get processed through these 5 different gates. And the forget gate, it determines how much we should forget the long-term memory, and the input gate is how much that input will add to the long-term memory, same the candidate gate, and then the output gate and the final gate is what we determine to be our short-term memory here. That could be used over time to predict what type of movement that person is using. And in this case, this sets of sequence right here apparently translates into a punch. But in my project, I implemented a lot more than that. I use kicks, front kicks, roundhouse kicks, side kicks, and punches. So with all those aspects in mind, this over here is my overview of the algorithm that I implemented in my system. And it starts off over here by receiving input from a video or from a live stream, which is hopefully an FPS of 30, and it calls the pose estimation model to generate these key points. And the pose estimation model, I used a pre-trained one called the YOLO version 8 model, and I believe it was very suitable for my use case because it tracks the 2 athletes and it gives pretty sound results with the key points over here. Then we calculate the angles, like I mentioned earlier. Then we have our LSTM classifier, and this ensures that the movement that the athlete is doing is a valid move. It's a valid technique. And if it is classified as a valid technique, then we go off into these cutoff percent. And however, I did remove this in my later architecture because this was not working and it gave false positives actually. So I actually trained a different model that added another label here called nothing label, so that the model wouldn't inaccurately predict a move even though there isn't anything there. And lastly, if it is a valid move, then it goes if it's near the body targets. And what I mean by that is that when a person generates key points here, I'm checking if the person who has the appropriate punch has his punch near the head or is inside this square or this polygon generated from the right shoulder, left shoulder, then in the hips from their opponent. And if the punch or kick is any of these situations, then we award that person a point. And let me show you my results. So I tested this model through my local martial arts dojo, and if you look right here in this specific example, when the person in the red kicks, the model actually didn't classify it as a side kick or roundhouse kick. However, in the next portion right here, he's about to do a reverse punch, it successfully identified that. And in this other example, my model seems to be very good at identifying punches or counting them. However, when the person in red, when he strikes the person right now, that moment there didn't register. And in this other case, you see right here, the fighters aren't exactly in the direct line of sight of the camera. So my model misclassifies that there's a hit on that person right over there. Obviously, looking at those testing results, I feel like my model is still very much in its prototype stage. It was able to identify those different punches, but unfortunately it wasn't very clear with the kicks. And I feel like that has to stem with perhaps the way that the joints are more calculated. I feel like that's a little bit more complex, and perhaps getting a different pose estimation model other than YOLO will yield better results. However, thank you for listening to my project. There's a lot more to be discovered on my CYSF doc. And thank you for your time, and thank you.